So this project, I got a little bit like die Jungfrau zum Kind, because I was asked and invited by Mirko van der Baan, who's a geophysicist here at the U of A, to join in a question that he wanted to study, but he had no idea how to. So this was sponsored by the Micro Seismic Industry Consortium, which is sort of, I think, hosted at the U of C. Maybe somebody can correct me later. And also benefited from one of the U of C's create projects in the same sort of field called Redevelop, which is on the bottom right of the slide. So to get us started, I thought, me explaining what fracking is probably not a great idea. And then I came across this video. And I'm going to show you snippets of this video. It's going to be a few minutes, but I think there's a benefit of doing that because it really leads into my research question and what this is going to be about. So off we go. And I'm going to move the cursor around here a little bit, but please bear with me. So this is by the Alberta Energy Regulator, and this is actually sort of semi-important here. And I want you sort of to listen a little bit to the, I guess, to the storyline that develops here in this video. And I'm going to fast forward to not bore us too much.
Keith wonders, how is natural gas extracted, and is it safe? He is about to have a conversation with Michelle, who works for the AER as a geologist or a rock expert. It's so nice to warm up and enjoy a conversation that really matters. Michelle tells Keith that most of our natural gas is extracted using a technique called hydraulic fracturing or fracking. Keith has heard concerns about hydraulic fracturing and asks, if hydraulic fracturing is so controversial, why do we even allow it? Michelle points out that hydraulic fracturing has been used in Alberta since the 1950s. And more than 100,000 wells have been drilled using the technique. In fact, hydraulic fracturing is now the standard approach used to extract natural gas in Alberta. And that's because almost all of the easy-to-get natural gas has been drilled in Alberta. But recent innovations in drilling and hydraulic fracturing techniques have unlocked new and vast oil and gas resources that would otherwise be trapped deeper underground. Keith wonders how hydraulic fracturing actually works.
So we don't need to listen to what Keith wants to hear about it. So a big portion of the video goes into some details on how fracking actually works and how the injection of fluid is conducted. But I want you to listen to the end of the video, which comes back again a little bit closer to what this presentation is going to be about.
Michelle wants Keith to know that the AER regulates hydraulic fracturing to make sure the public is safe and the environment is protected. If a company wants to drill, they start the process by leasing the mineral rights from the Alberta government. Then, the company drafts their project plans while consulting with stakeholders, allowing their concerns to potentially influence the design. After listening to the communities and completing complex site and project assessments, the company must submit a detailed application to the AER. The AER then reviews the project, which can take several months to complete and sometimes involves public hearings. If the AER determines that all application requirements have been met, it will issue an approval or an approval with conditions. And their job doesn't end there.
So in this video, you hear all sorts of buzzwords. Let's start with the back end of it. Consultation, hearings, information, strict regulation, and if all of this was so crystal clear, we could say then why do people talk about fracking whatsoever? It's just a technology that has been around, especially here, for a long time. Why would it ever be controversial? But through this project and conversations with lots of industry folks and also my colleagues here, the question, the jury is still out on what the public really wants fracking to be in Western Canada and whether they sort of believe the regulation and they trust what's happening in the industry. So that brought up the question of what really is public perception and what is the public sentiment regarding hydraulic fracturing like in Western Canada. The questions came from both sides. The AER, the regulating side, the political side wanted some more information about how to better educate and how to better speak to the public about hydraulic fracturing, avoiding the jargon and instilling trust, because they feel there is a bit of a crisis in the oil and gas industry when it comes to sort of support and trust on a broad basis. And the micro-industry consortium was specifically concerned about this notion of seismic activity, induced seismicity, and earthquakes. If you tell somebody on the street that hydraulic fracturing, so the natural gas that we consume in cooking, comes actually at the risk of earthquakes, you could see a lot of people sort of going, oh, I didn't know that. I don't want that to happen. So the factors that seem to be at play are specifically the environmental concerns that linger under the surface when it comes to hydraulic fracturing. But also on the other hand, and that makes this kind of interesting for an economist like myself to study, is that there is significant job creation and economic activity and investment related to hydraulic fracturing and the entire energy sector in Western Canada. So we're kind of interested in investigating the balance between the two. In this balance there are certain sort of framework conditions, I call them, that have received sort of little to no, I find, at least academic research and are not well understood. When we think about benefits and costs of hydraulic fracturing, we can see that some have the benefits from job creation and investment, and others just have to put up maybe with the potential risk when we think about society. So there's very little organized research that looks at the distribution of these benefits and costs, and whether people agree that the process that the Alberta Energy Regulator here talks about in terms of making sure everything is safe and sound, whether that actually is fair and square and instills trust within the general population. So what we did in this project, and we have presented this to the Department of Energy, to the Micro Seismic Consortium and industry members, we've presented to members of the AER, the regulator, earlier versions of that, is we want to investigate public opinion around HF. We want to better understand what the public thinks and feels and prefers when it comes to hydraulic fracturing, and that's specifically of interest to the regulator. And for the oil and gas industry, and especially sort of, the consortium and the big industry bodies, it's about advancing and improving communication so that they can better instill trust in what the industry does and together with the regulator. Second, the specific sort of goals of this project, and maybe a paper that comes out of, is sort of looking at how do individuals balance and value the benefits and costs around hydraulic fracturing projects, fairly concrete project proposals. And we want to quantify how they view the economic benefits against the potential environmental and also sort of social risks that come with these project developments. And because it's a geophysics project initially, the focus is on what happens to that balance of that perception of the balance of benefits and risks when we throw induced seismicity into that mix. So off we go. Together with other colleagues, we had done some national surveys around perceptions of energy industry across entire Canada. And interestingly enough, shale gas, which is created through fracking most commonly, is sort of like people don't really seem to be knowing at a national level how to distinguish shale gas maybe from other energy production sources like regular natural gas or oil and gas. And so you see the support seems to be on the low double-digit percentage side nationally on average, not speaking for Western Canada. But when we asked individuals across Canada when we asked Albertans about energy sources, and specifically landowners that also have a role in this question of shale gas or fracking, then natural gas seems to be the most, or if not, it's the most supported, strongly supported source of energy in at least Western Canada. So I stole this from a paper by Atkinson et al. 2016, and it gives a little bit of an overview of the extent of where these 100,000 wells that have been fracked since the 1950s, where are they located? And so Edmonton would be sort of, I guess if I use my cursor, so somewhere out here to the east, and Calgary a bit closer. I'm not really sure whether Calgary would just be about maybe down here northeast of the H letter. But you see that along the foothills of the Rocky Mountains here in our beautiful province, it's all red dots. So these are all HF wells that have been fracked between 1985 and 2015, at least here. So what did we do? What's the methodology? And Vignette members have heard similar things from me before. So we've conducted an online survey, ended up getting 1,310 responses from people in Alberta and BC, British Columbia. And we asked a whole range of questions that both the literature and we believed are relevant to understanding how people view these benefits and risks. Where do they live? How long have they lived? And how strongly are they integrated in their community, place attachment and community values? Where are they employed? Possibly in the oil and gas industry. Where do they get their information from? Do they get it from Facebook, from the New York Times, from the CBC television stations? What do they know about hydraulic fracturing? Objectively, when we ask them about definitions, but also how would they rate their own knowledge? Like, I know a lot, I have no clue, and anything in between. Can they accept hydraulic fracturing without any sort of extra information? What do they think about hydraulic fracturing in their community? Is there anything close by or not? Anything in terms of perceptions, viewpoints around the oil and gas industry in Western Canada in general? And then we asked them about, who do you trust when it comes to your oil and gas industry and fracking? Are these stakeholders transparent in terms of how they communicate what they do? Who should be responsible for making sure this is a safe energy extraction? And then, have you ever experienced any earthquakes in your community, in your place of residence? And then we asked them some demographics just to better understand who these individuals are. In part in this survey was a vignette experiment, which is called Factorial survey experiment. And I'll explain this in a second. So this is an evaluation method by asking people something that they then are asked to evaluate that uses non-monetary values. So we're not asking for people to pay or accept something. There's no transaction involved here. We just ask them to rate something. And this is a fairly new approach that actually comes from the social sciences that's actually applied in the energy literature. So a few colleagues in Germany have worked with that. My colleague, John Parkins, that some of you may have known by name. We have just done another paper on wind power earlier this year. So the advantage of this vignette approach is it allows you to describe real life situations without having sort of dollar values or euro values floating around that may get people to think about something very differently. But it's also a challenging task. It's not something where you can click and provide responses on a per second basis. It needs some thinking by the individual involved in this task. So vignettes are short and carefully constructed descriptions of all sorts of things. But the key issue is they systematically combine certain characteristics or attributes in that text, in that short description that you want a participant to sort of read, think about, and then provide a response on. And that response is often described as a stated preference, like from 1 to 10, 1 being I hate it, 10, I love it. 1, I would never accept this, 10, I would readily accept something like this. So these sorts of stated preferences. It actually comes from the social science field, but it's sort of creeping into the economic field because it's a preferred approach when you want to measure acceptance or preferences under things that economists have a hard time measuring, and economists want to measure stuff with values, and those are fairness, justice, equity, social norms, and things like that that are almost impossible to put into values from 1 to 10. But in these vignettes, you can integrate them indirectly and allow people to wrap their head around it. So a few papers in the economic literature have used that, and I'm just going to pull up an example of what this sort of looks like in reality. Okay, the key issue why we use it here is that we want to measure individual preferences and then also the characteristics of these individuals that we typically do not measure in economic experiments or in other economic studies. And then, of course, how do the preferences and the characteristics influence this specific question here, the acceptance of hydraulic fracturing? So here's a study in the labor economics literature. And that's where this approach has been used most often, I think like 5 times or so far. Imagine you are a hiring manager and you get to see lots of CVs, and then you get to decide who to hire or invite for an interview. And in this literature, they use these vignettes to measure sort of biases against women, bias against minorities, and so on. And so you would, the participant would see many of these short CVs and then always be asked, how likely are you going to invite this applicant from 1 to 10? So that these are sort of the tasks where you can hide, for instance, gender or ethnic minority in something that is otherwise very familiar to an individual. And that's the advantage here of using this technique as opposed to another technique for evaluation methods in economics. Our colleagues in Germany, Ulf Liebe and others that I think are in Dresden, they have used this for the first time in sort of an energy economic context by studying acceptance of wind power. And so you see here the text of that vignette, that description, and so radius of 10 kilometers, 15 turbines, electricity is produced and exported. Those are all that's the combination of these specific characteristics that these colleagues wanted to have evaluated on a scale from 1 to 11 here at the bottom. And again, the question is acceptability, which is sort of otherwise difficult to measure in economic terms. We use this same sort of design or method, and we want to describe hydraulic fracturing projects hypothetically with a combination of characteristics or attributes that reflect that balance of benefits and risks and so on. And so we want to do that in a community context and not just ask the individual about what you think, but what do you think about this in the context of where you live, because it does affect your place of residence a little bit. So proximity and sort of that not in my backyard argument is of course key here. We want to measure environmental externalities of fracking, which is noise and dust pollution, light pollution at night, things like that. And we describe that sort of mainly as a traffic variable because it also affects road infrastructure and stuff like that. Then the time, meaning the intensity of those pollution, traffic, and so on, 24/7 or just 3 hours a day, things like that. And then sort of key factors that have come up in this project as being sort of interest to the outside stakeholders, the partners. How keen are people on consultation, which has come up in Canada repeatedly with indigenous communities and energy development. And the entire energy sector I think has a mixed reputation when it comes to consultation with communities and the public. But also compensation. What would it take to get people to accept hydraulic fracturing if we offer them forms that just of not necessarily payment, but maybe also payment that just recognizes this is affecting people's lives. And if we compensate them, can we get some people to say, okay, fine, you compensate me, I'll put up with the noise, for instance. And then last but not least, how do people react when we say, well, there's actually a chance you have a little earthquake as we are fracking, here in your backyard. Is this going to throw people completely off, or is it okay? So here are these variables, here are these attributes, and then we have them in different levels. If we take time, for instance, option 1, all hours of the day, and option 2 between 8 a.m. and 8 p.m., which is a bit more acceptable if you think about good night's sleep. So we implemented this survey late in 2018 into 2019. We did snowball sampling because we didn't have much money for some formal recruitment. We used the U of A put a media report out with the colleagues, described the project. Student had a nice smiley picture. We did other news reports. We did a lot of the student actually did a lot of social media work to recruit participants, specifically in communities that are known for their fracking activity. And then we let this run for about 3 months, and we collected these 1,310 individuals. These vignettes were implemented in a way that's very common to choice experiments, if you've ever heard of this. So you take these attributes in their levels, and you basically multiply this out, all possible combinations. And that would give us just over 1,100 possible combinations of these descriptions. You can probably think that some of these extreme combinations make no sense whatsoever, because you can have not just all the benefits and never any risk, and just all the risk and never any benefits. It's probably not what we want to test. So you use a special design, a subsample of these total vignette numbers that basically allows you to capture 90% of the meaningful variation of these combinations, which brings us down to a manageable level of 144. We use an 11-point scale to measure this from 0 to 10. Other people have used 0 to 100, or 0 and then +5 and -5. We use 11 points. And we ask each individual in the survey to evaluate 6 of these scenarios. Multiplied by 1,310 gives us about 7,800 evaluation, which means that each of our 144 vignettes is evaluated 53 times. Just in terms of statistical power, this is actually a really nice value, because other studies sometimes only have 15 evaluations or so on. So that matters when it comes to the formal analysis. Okay, here's an example of what this looks like. And in bold, you see the actual attributes that are varied in terms of their levels between each of the vignettes or the scenarios that a respondent would rate. So proximity, number of trucks, all hours of the day, and so on. And then, for instance, at the bottom, seismicity related to the operation is anticipated to be persistent and repeating, but too small to cause any structural damage. So the element of structural damage, or not a sort of, if I'm a homeowner and all of a sudden I see my foundation crack, that may not be what I want. So I have a lot of results, and I hope I can go through them in a way that sort of makes sense, is not overwhelming, and I can finish in time. So I'm going to start off with some plain social demographics of the respondents, because snowball sample typically means you get a biased sample by the people that feel they want to participate in a study about fracking, and you don't get a representation of the Canadian population or the Alberta population. But we were quite happy. We have a really nice distribution of our age variable. So we did not just attract young activists or grandmas that happen to be on Facebook and had enough time to participate. That's a good thing. Happy about that. Is it important? I don't think so, but we're happy with the distribution. Gender. If this is something only oil and gas workers would do on their phones while they take their coffee break, that would not be very informative. We get actually a fairly nice distribution between, the main 2 genders that we talk about these days. And then we believed, and the literature talks about this a lot, that different levels of knowledge and education also have an effect on how people view energy and oil and gas in particular. We have a fairly nice distribution here, but of course, because it's a university study, we are a bit biased towards graduate and postgraduate education. But it's okay. We have some people with no formal education, and we have a good chunk of high school educated individuals too. So here are our respondents when it comes to energy experience. And because we do this in Alberta and BC, mostly in Alberta, a little bit in BC, we got to worry about people working in the industry or having relationships in the family with people that work in the field, because that will presumably influence the way they think about it and how much they know about it. So we have a bimodal distribution here. We have a lot of people that have close relations, either by working directly or family, and we have those that have no connection whatsoever. And then we have in the middle folks that work in sort of affiliated fields that may, spike their interest in this topic or spike their concerns for environmental impacts and so on. And that's sort of the takeaway message here when it comes to experience. When this is always asked, like, do you support the energy industry or do you not? And interestingly enough, our respondents supported everything but coal and nuclear. If you look at strongly supporting green and somewhat support, and that color scheme is going to be with us for the rest of the time. So more orange and red means thumbs down. I oppose, I don't like it. And then black being not preferred to say. We have very little people opt out, but oil and gas, you can see, is among the highest. It's kind of surprising that geothermal is very high. It's been talked about a lot, but to my knowledge, is sort of still in its infancy around here. Wind is not preferred, and that's what our other paper with my colleague John clearly shows. Nobody likes wind because of the big wind turbines. Kind of makes us like Germans. But solar is actually something people can wrap their head around. We asked them, okay, so how acceptable do you find hydraulic fracturing, without giving them information or anything like that, so cold? And it's kind of interesting to see that when asked cold, over 50% of people find it, acceptable or strongly acceptable. So that's important to understand, that there is support for the gas industry, and people don't seem to be caring so much about what it may entail, the fracking. When we asked them about certain risks or what they see as risky when it comes to the exploration of and the exploitation of oil and gas products, you see that transporting petroleum products and placing oil and gas wells near drinking water resources, and also the economic reliance, so the 3 columns on the right-hand side or the 3 packages on the right-hand side, seem to be more worrying to people than actually hydraulic fracturing, which is on the far left. So people are concerned about transporting oil. They are increasingly concerned about the economic reliance on the sector, which is a big political topic and has been for a while around here. And then anything oil and gas touching water. Pipelines, which is the 3rd one from the left, is interesting. And we did this study certainly not in a vacuum of politics and information and debate. So for people that live in Alberta, you know, Jewel and so on, you probably, hopefully nodding a little bit, people are pro-pipeline, 35.2%. And pipelines, based on their record, are the safest way to transport oil and gas around. Environmentalists would politely disagree, but I'm just going to say that. So not surprising, but interesting to have the numbers in front of us, I think. Then we asked them, okay, so what specific concerns may you have with hydraulic fracking in particular? And it is water that comes out on top. Groundwater, surface water, the water use and the chemicals and the sand and all this other stuff that goes into fracking operations. That's what people are most concerned about. What they're not what they're not concerned about is on the right-hand side so much odors or light pollution, like so those direct operational impacts that might be felt very close by is not of immediate concern. Induced earthquake on the left-hand side of this graph, you know, there are about 50% of people that would say they're concerned about it. But if we wouldn't have asked about it in this question and maybe just like put this question, are you concerned about earthquakes in Alberta? I'm sure people would have not picked up that much on it. So it kind of comes, people realize, yeah, and yeah, now that you talk about fracking, I know as much as it sort of fracks the rock. And earthquakes, yeah, oh, I don't want earthquakes, of course. Here is a lot going on. And maybe you can just see on the top row, in the middle, overuse of local fresh water and groundwater contamination stand out because of their peaks of the red and the orange. Induced earthquakes are, again, along the lines of a few others. If you go to the second row, so these are the individual attributes that we are interested in, but we have not yet looked at the results of the evaluations that people gave. You see, it's this not much that stands out again on the bottom, but again, the surface water is a concern to individuals, and to a lesser degree, many of these other negative externalities. So now coming to trust and transparency, these other things. People do trust on the very left-hand side the oil and gas industry. They do trust the regulator, but somewhat, not strongly necessarily. They don't trust politicians when it comes to what they say about the oil and gas industry. And then, you know, I see Ralph smile. That's probably universal, or at least transatlantic in that sense. We don't even have to talk about environmental organizations in Alberta. They do trust local municipalities. So that's the political level that people trust in. And it's not so clear that our provincial government is much appreciated. I need to say at this point, we implemented a study around the transition from our left sort of SPD government into a more hard right UCP government. So like, I don't know if I can call the CSU UCP, maybe that's a bit unfair, but anyway, we went from left of center to clearly right of center, and a lot of oil and gas aficionados were a bit less happy with that government, and so provincial government didn't get a good feedback here. And then the last question before we go into these vignette results, we ask about, so when it comes to oil and gas and fracking and so on, how would you rate the industry stakeholders, not the public, the industry, when it comes to transparency? And again, people find the oil and gas industry to be transparent. And then you see a lot of mixed results. And then they certainly don't like or think that environmental organizations are transparent. And so if you thought so far there might be a little bit of a political affiliation effect here, it certainly is. I like oil and gas, and anybody who poo-poos our oil and gas industry is a enemy of the state. And environmental organizations have been in the political debate, whether they are foreign financed and it's those bad people from outside, they ship money here and then they put these protest signs up, and that's poo-pooing on our pride and joy, which still is the oil and gas industry. I'm sort of overplaying this a little bit here. It's not necessarily an academic interpretation, but you can totally see how this is in the background. And again, provincial government, when it comes to transparency, at the time it was this NDP government, left of center. It was not trusted to have the best interest of oil and gas in its focus. Okay, so we asked people, everybody got 6 scenarios to evaluate, to a total of here 7,600, not 7,800. So we had a few people drop out or not answer this section. What you see here is the distribution of the frequencies, so the numbers of 0 votes all the way to fully support 10 votes. So you see we have, again, a strongly bimodal distribution, and that's mainly because we have 2 groups. One group, which we call keener, 7% of all votes, that consistently clicked on 10 for all these 6 scenarios. We have their response time. So if anybody just raced through the survey and just click to finish it, we threw these people out. So these are people that read the scenarios and liked everything we said. Like, any fracking project, yes, go for it. On the other hand, we have 13% of people that said, no, I don't want the scenario. No, I don't want the scenario. So they both groups want to send a message. One group says yes, other group says strongly no. If we take those out, we still have a bimodal distribution. And you see, otherwise, there's no distinct feedback on these scenarios in terms of preferences or liking or perceived acceptability. What we figured out fairly early on is that because of the linkages and the experience respondents have with the oil and gas industry, let's just check what knowledge, whether there's a relation between the mean rating and knowledge. And you see that the more knowledgeable these people were, based on their stated knowledge, so like I think I know a lot about this, subjective, there's a linear relationship between knowledge and the rating. So people that knew more about it, presumably were employed or had close employment ties to family, were more likely to give these scenarios a very positive evaluation, independent of what the specific mix was in these variables. So I'm going to go through some individual ratings, and then I have 2 more slides and then we're done. So when you see location, it slopes up to the right, meaning the further this fracking project is away from where I live, the better. Typical NIMBYism response makes a lot of sense, has been shown in the literature many times. And who wants to have a fracking well right in their backyard or beyond their gate? If it's 15 kilometers away, I don't see it, I don't smell it, sure, go ahead, do it. Trucks. It's a bit surprising. I would have expected people want fewer trucks more, but here the jury is still out. Maybe people can't really envision whether the trucks will be driving by their front road or so, but anyways. Time, clearly a preference for 8 a.m., 8 p.m., but remember we have quite a few individuals that said, sure, go ahead. So all hours of the day seems to be not far behind, although most people probably would realize once those trucks are driving by at night that they don't like it. Consultation is a little bit sloping up to the right, so people do like to be consulted more than just a project appearing on the edge of the village, for instance. Consultation is appreciated just by itself without anything else considered. People do like benefits. We gave them benefits, as you see in the bottom. The company's hiring locally, which would be employment benefits. The community gets a cash grant, which is something that wind developers and all oil and gas companies have done in the past by donating $50,000, $200,000 to the community to build a new ice rink or to renovate it. That's much appreciated. And also community projects, which are a little bit vague, but people do like that investment in the community. So they may have interpreted community projects to be very different, but they like it. And as we would expect, seismicity, the more the frequency, so not necessarily the frequency, but the severity. And this dark green reflects infrequent but large effects with potential impacts on the structure of buildings. So this will be damaging houses, and people clearly don't like that to happen, even if it may be extremely infrequent or 0.000, but that's just the thought of my house going to the fritz, people cannot accept that. So we do see that consultation benefits and seismicity do matter more than the other sort of externalities that we already saw up in these just individual questions in the survey. But here we have them combined in these scenarios. So what economists do with all this stuff, we stick it into regression models. We want to measure causality. We want to understand how the variables, when we put them together and not look at them in isolation, whether they influence each other. So this is basically one of two models. I'm not showing you the second model. Just what are the effects of the attributes on the level of the ranking of a scenario. Location, far distance, 0.961 means the further away, the more likely somebody was to give it a higher rating. Many trucks, decreased rating. Consultation, full two-way consultation. So community has a real ability to cancel or direct a project, much appreciated. So is community benefits, not individual benefits, but investing in my community is very much appreciated. And anything to do with seismicity. So here we control for all these factors together. So we can actually say that seismicity matters significantly in the evaluation and the preference for or against hydraulic fracturing projects. The moment seismicity shows up as a word in a scenario, this scenario is going to be dumped a little bit lower, which is an interesting result. What we have not here in this model, and that would be an extension that we would do in our academic work, is what respondent characteristics, how would respondent characteristics, age, gender, employment, other views of oil and gas, how would they influence these ratings? That's typically something that's done as a second stage to have sort of the effects of the individual who rated these scenarios reflected in the overall model. And that's it. I didn't, I think I jumbled up my final implications or takeaways. So down at the bottom is only the end. And these other figures I didn't even want to show you because we experiment a lot with, can we actually overlay earthquake experience with fracking wells and with perceptions? Do we see consistent hotspots? And we don't. But what we take away here is actually that these so far unexplored variables in combination with seismicity is something that both the regulator and the industry need to find a way to talk to the public about. So the purpose of this project was to generate information, quantitative information, for both communication, to improve communication by the industry, and also have the regulator, give the regulators some information about how to talk to the public. Whether they'll be able to do that, I don't know, but yeah, we did our part. Thank you, that's it.